Hello students, today we are going to take up the topic colloidal state under surface chemistry part 2. Let us start the topic with a very good thought. Every morning when you wake up, you have two choices, be positive or be negative. It's upon you to decide that what you want to be. Okay, so learning outcomes from this video lecture is characteristic of true solution, colloidal and suspension, types of colloidal system on basis of dispersed phase and dispersion system, medium, lyophilic and lyophobic zone, and the multimolecular colloids, macromolecular colloids, associated colloids. Let us start. So before taking up the study on colloidal state, we can understand about what is the history behind that. Earlier we were not knowing the particle size of the colloids or any solution. Earlier in chapter number 1 we have discussed about the solution, which is composed of solute and solvent and is homogeneous mixture. But here what was the history behind that? Earlier the term was known as crystalloids. Crystalloids means crystalline substances which can pass through animal membrane. Animal membrane, like it's made from the fat, and the solutions which are crystalline like sugar, urea, sodium chloride, that is easily passed through this membrane. So that's why the name was termed as crystalloids. Similarly, some of the substances like amorphous substances which were unable to pass through membrane, that was termed as colloids. As the time passed, it was very difficult to include all the solutions under these categories of crystalline and colloids, because after the advent of these polymers and all that, it was very difficult to classify these solutions on the basis of crystalline and colloids, because there was wide range of particle size, and even though some colloids were able to pass through crystalloids, so that's why some solution was means amorphous substances that was able to pass through the membrane, so that classification was ruled out. Now the new term was found, so they come to know that this is not the membrane and all that, this is the particle size which is deciding the particles will be retaining on the surface of the membrane or it will pass through. It depends on the particle size. So every discussion and all that was based on the particle size. So now, for example, all the solution available in our present situation, the present environment, all are colloidal solution, and therefore it is appropriate to say the colloidal state. And what this colloidal state means, the particles of the solute in a solution having a range of 1 nanometer to 100 nanometer, and most of the solutions comes under this category, be it a blood, be it a gelatin, or number of solutions we will come across. We will now see the examples. All the solutions will come under this category. Colloidal solutions, particle size are intermediate between true solution and suspension. Now we will discuss about small term, that is true solution, colloidal and suspension. So let us see what makes the difference. True solution, for example, if I am taking sodium chloride and put in the water, solute is added in the solvent water. If you make the solution, that solution is transparent in nature, and if you pass through any filter paper, and it will immediately pass through. So it means that is a true solution, and after the solution seems to be homogeneous, so that solution, true solution. The particle size is very small. The next part is like blood. Blood is coming under colloidal solution. Milk is coming under colloidal solution. Jellies, jams, pickles, all are coming in colloidal solution. In that any creams are there, face creams, all liquid, gels, glycogen, medicines, liquid medicines, all coming under colloidal solution. The particle size is deciding that. Now, if the particle size is very large, let us say I am having sand plus water, that particles we can immediately see also, that is a totally heterogeneous system. and that particles are known as suspension. The particle size is very large. It cannot pass through any membrane, that's animal membrane or any simple filter paper is there. So therefore, this classification basically true solution, colloidal and suspension is based on particle size. And what is that? If the particle size is between 1 nanometer to 100 nanometer, and some books it is written 1000 also, that is colloidal solution. Okay, so now the true solution, suspension and colloidal, what are the properties, what are the parameters, what are the characteristics which is differentiating these three solutions? Our chapter, that colloidal chemistry, surface chemistry, is based on colloidal solution. This true solution, suspension, for the comparison only we are discussing now here. Nature, as we discussed, that salt and water solution is totally homogeneous. So therefore, true solution is homogeneous. Particle size is less than 1 nanometer. If you compare with colloidal solution, it seems to be homogeneous, but actually it is heterogeneous. And the particle size, as we discussed earlier, 1 nanometer to 100 nanometer. If the particle size is greater than 100 nanometer, that is suspension and it is heterogeneous. Similarly, sedimentation. You see that if particle size is more, sedimentation will take place. If particle size is small, it will be always in the state of motion. You know the gravity. More will be the weight, more will be the gravity. So that's why the force. If you see the terminal velocity and all that in Stokes law, if you see the particle size is deciding the settling ability, sedimentation. Lesser is the particle size, lesser will be the settling rate, and more is the particle size, more will be the settling rate under the gravity. Diffusion, the same is case for the diffusion. The particle size is small, diffusion will be very fast, and suspension, particle size is very large, it won't diffuse. Next is visibility. Visibility, as we discussed already, that visible, the solution is made, it is not visible, the particle size is small. And if you talk of colloidal solution, because the visibility as such is not there, but under microscope, that also ultra microscope, we can see the particles. And one property is there, these particles scatter light, and light falls, illumination will take place. So therefore the scattering will take place. This property makes it different than the other two solutions. Particle visible by naked eye or under microscope in case of suspension. Similarly, filterability, you know already that animal membrane, the true solution will pass easily, and the colloidal solution pass through filter paper but not through animal membrane. But suspension, neither through animal membrane or filter, it won't pass. Appearance, clear and transparent, and the colloidal solution is translucent and opaque. And all the ice cream, jellies, jam, butter, all are coming under this colloidal solution. Whatever you like very much, that will might be coming in colloidal solution only. Okay, now we are going to discuss, this is just the basic groundwork I have prepared. Now here in this video lecture, we are discussing only the classification of colloidal system. It is a full-fledged theoretical long chapter. Slowly we will discuss small topics on the basis of dispersed phase and dispersion medium. What is that? Dispersed phase, dispersion medium, solute and solvent. Now this term we are not using under sol. Sol means colloidal solution. So 8 combination is possible depending on the 3 states of matter: gas, liquid, solid. Gas is not included in this. That's why 8 I told, not 9 I told. I told 8. It means gas, liquid, gas, solid, liquid, solid, liquid, gas, and solid, liquid, solid, gas, solid, solid. So these all combination are there in the 8 combination in the dispersed phase and dispersion medium. Dispersion medium, that is present in more quantity or solvent. Okay, dispersed phase, solute particles. This is the basic combination. There will, in the next slide we will see. Second is on the nature of interaction. Interaction means forces. What are the forces existing between that? Lyophilic, lyophobic. Philic means water loving. Phobic means water hating or repelling. Third is the basis of type of particles of the dispersed phase. Type means very small particles are there. Macro means very large accumulation is there. And then associated colloids, that under certain concentration only association takes place. These are the 3 combinations we will study in detail. Let us start with the first one, dispersed phase and dispersion medium. So what do you mean by dispersed phase? As I have told you already, in the phase constituting the colloidal particles it is dispersed is the phase constituting the colloidal particles. Means what colloidal particle, what is the phase? Phase means which solid or liquid or gas. In a colloidal solution, for example, ferric hydroxide in water, this is a colloidal solution. Now ferric hydroxide are colloidal particles, and that will be having the size range between 1 nanometer to 100 nanometer, and that constitute the dispersed phase. Similarly, in this same ferric hydroxide in water, the water will be known as dispersion medium. It's not only that water will be, it may be alcohol, alcohol will be there. So that way the different medium can be there and different sols will be termed as. Now 8 different combination in this manner. As you see from this dispersed phase, dispersion medium, gas system is not here. Okay, so because that gas system will comes under homogeneous. So homogeneous, you know that this is not the characteristic of colloids. It seems to be homogeneous, but actually it is heterogeneous. Similarly, solid means dispersed phase and dispersion medium solid, and that type of sol is known as solid sol. Similarly, soil liquid, that type is known as sol, simply sol. Okay, any solid solute is there, liquid is the solvent, and then this is a sale. But normally we are not using the solute and solvent now. Now we are using dispersed phase and dispersion medium. Solid and gas. Gas is more. Whatever is dispersion, it is more. Aerosol. Liquid, solid. Solid is more. So gel. Liquid. That is emulsion. All we are talking of medicines. Liquid medicines are there. That is coming under gels. Or gels are coming under cheese, butter, jellies, and emulsion. That is coming under emulsion, like glycodine is there. Or any syrups are there. Medicinal syrups. Liquid gas. Aerosol. Like spray and all that. Okay, gas solid is more here. Solid, we must stone, foam, rubber, and gas liquid is foam. It can absorb moisture. So these are the examples. Solid sol examples are colored glasses, ruby, gem. Solid liquid is more here. The paint. Okay, and aerosols. This air is more, gas is more, smoke and dust. Gel, solid is more. So cheese, butter, jellies, emulsion, milk, hair cream, foam, mist. Insecticide spray, solid sol, stone, foam, rubber. So here solid is more, that's the reason. And under foam, froth, whipped cream, soap lather, liquid is more here. Okay, so this is the 8 different types of colloidal systems under dispersed phase and dispersion medium category. Now some terms are used like sols. Whenever the term sol is used, you just remember that it is solids in liquids. Means dispersed phase is solid and dispersion medium is liquid. If the gel is used, so you can just see that liquids in solid. Liquid is dispersed phase and solid is dispersion medium. Similarly, if emulsion is there, liquid is dispersed phase and dispersion medium is liquid. Similarly, dispersion medium can be water, so that is known as aquasol or hydrosol. If it is not water, if it is alcohol, so that sols are also known as alkosol, where dispersion medium is alcohol. Alcohol means ethanol or any of the propanol and whatever the good solvent is there. Now the difference, basic difference, as I have told you already, philic means water loving and phobic means water repelling. If water loving is there, so it will be stable. If it is stable, then it will be reversible. Okay, so let us see. And if it is not stable, it will form precipitates. If precipitate is there, it will be unstable. Okay, and if unstable, that will be having charge. So these are the small things we should keep in mind. So what are the difference? It can be prepared easily, because water loving, so definitely prepared easily. Here cannot be. Second is stable. Yes, because it is water loving. It is easily precipitated. It's not stable. Simply addition of small amount of electrolyte. If how you can remember this? For example, you are having muddy water. Muddy water is there, dirts are there, dirt particles are there. So what you are doing? We are adding alum. Alum what is doing? Alum is helps in the settling. So that means that helps in the settling means precipitation. So precipitation is linked with lyophobic. Similarly, reversible nature. It can immediately be reverted back to the normal state. Okay, and here irreversible nature. Once precipitation takes place, it's very difficult to get it back into the solution. Similarly, surface tension is lower. This point also can be asked in the exams. Dispersed surface tension, what is it? Surface tension is lower than the dispersion medium, and their surface tension is nearly. Now you see why you are using soap for cleaning clothes. So soap is doing what? It is decreasing the surface tension. Okay, so that is the meaning basically happening with the soap. Action is also related with colloidal solution only. Now lyophobic, phobic means liquid hating, and metal sols, metal sulfide like silver sulfide, gold sulfide. So all these sulfide ores, PBS, all these are coming under lyophobic because it can be easily precipitated. Lyophilic, water loving. Water loving means gelatin, jam, starch. These are easily formed and it is stable, it is reversible. So, and having less surface tension. So all these things are important in terms of knowledge. Okay, now so these are there. Earlier we have discussed already. There are in the book. If you find so many other area also, you will find out, like Tyndall effect. Lyophobic, more scattering will be there, and lyophilic, less scattering will be there. This is small detail might be there. And one more thing I have told you already, may or may not migrate, carry charge and migrate towards the node or cathode. Means lyophobic are always containing charge, because due to charge containing only the neutralization is taking place. That always you keep in mind. And mostly of inorganic nature and organics, this detail is there, but basically 4-5 properties which we discussed now here, this is more important than anything else. If any question is coming, basically 2 marks question is coming, you can write 3 different, that's all more than sufficient. Okay, for one's knowledge, you can read all the properties. Okay, next term is classification based on multimolecular, macromolecular associated. Previously we have discussed about the classification of colloids on the basis of the dispersed phase and dispersion medium, and along with that we have discussed with the interactions, the forces of interactions between the dispersed phase and dispersion medium. Now we are discussing multimolecular, macromolecular associated. Whenever macro word is coming, you always keep your attention under polymers. Polymers means polymer is macromolecule having high molecular mass, and association when word is being used, you always keep in mind the soap action. Okay, so it is very easy to remember all these things by linking with certain examples, so that it would be easy to understand and remember. Multi means very small. So here in this case, the particle size is very small, but small molecules can combine together. They are formed by aggregation. Aggregation means combining of a large number of atoms or molecules which generally have diameter less than 1 nanometer. Means the particles were having less than 1 nanometer size, but they associate, they join together and form the colloids which is having particle size 1 nanometer to 100 nanometer, which is following the colloidal range. So okay, so what are the examples? Gold and sulfur. Gold and sulfur, you should be aware that all metal sulfides are coming under which soul? That are coming under phobic souls. Okay, hydrophobic souls. Previously we had discussed hydrophilic and hydrophobic, or lyophilic, lyophobic. Hydro, water is there, and lyo, any solvent could be there. Okay, so and multimolecular colloids, molecular masses were not high, and atoms or molecules are held together by weak van der Waals forces. Okay, now as compared to macro I told you already, polymers, they are molecules of large size. So large size molecules are there, we can break into the normal size of 1 nanometer to 100 nanometer. So that comes under the category of macromolecular colloids. Polymers like rubber, nylon, starch, they have high molecular mass. Due to long chain, the van der Waals forces of holding them are comparatively stronger. Why? Because you know the van der Waals forces depends on surface area. More is the surface area, more will be the force, van der Waals force. Association. Now here they are formed by aggregation of large number of ions in concentrated solution. Here very important point to understand is, here the concentration is deciding each and everything. At low concentration, these ions were acting as electrolytes. Electrolytes means that the particles are having less than 1 nanometer particle size is there, but at certain concentration, these ions can combine together to form micelle. So that micelle we are coming next, we are discussing in detail. Okay, so these small ions, if concentration is very less, the ions will be existing in the form of electrolytes. They were separated and they are not joining together. But as the concentration is increasing, they are joining together and they are forming micelle, and micelle is having some particular range, 1 nanometer to 100 nanometer. That's what we are doing as associated colloids. And the perfect example is soap solution. Soap can work if it is at particular concentration. Their molecular mass are generally high. Higher is the concentration, greater is the van der Waals forces. So now I would like to discuss more about associated colloid. Let us start. So here critical micellization concentration, that is very important definition, Kraft temperature also. And before that, what is micelle? Micelle is formation of aggregated particles. Here particles are joining together at higher concentration. If the solution is dilute, the particles will be in the ions. Ions will be there. But as the concentration increases, these particles will join together, and the particle size of that particle which join together will come under the colloidal state range, that is 1 nanometer to 100 nanometer. Okay, so soaps and detergent works good when it is having certain concentration. Why? Because at that concentration only micelle formation takes place, and that concentration is called CMC. CMC means critical micellization concentration. It is the specific concentration above which micelle formation takes place. For example, soap. And one more definition can be asked is craft temperature. It's the temperature above which micelle formation takes place. Okay, so now I would like to discuss about the cleansing action of soap. Now see, soap is what? Soap is basically formula, if you see, RCOONA. R is what? R is the alkyl group. Alkyl group is having nearly 17 carbons. Okay, see, if 17 carbon is there, or 11 here, they have taken 11 carbons. See here, 11 and this one 35. Okay, so here 17 should be there, not 11, because 17 only will make 35. Okay, C17. Let us say sodium stearate is there. That is a soap. Sodium stearate means C17H2N plus 1. So at 17 into 2, 34, 34 plus 1, 35. So this is the soap, C17H35CONA. Now in this soap molecule, the two parts are there, polar and non-polar. CO negative and Na. Negative Na, this is a polar charge ion, and this is R part is non-polar part. So non-polar and polar part. Now we know that two words we are aware of, hydrophobic and hydrophilic. Hydro means water and phobic means repelling. Hydrophilic, water attracting, philic, loving. So CO negative Na part is a water loving, because this is the polar part and this part is non-polar. And this, why, what is signifies this? It signifies the number of carbon. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will be a long chain, that is known as tail. So tail is a R. R is what? C17H35. So the R is a tail. Tail is hydrophobic, and hydrophobic is water repelling. So now what happened? Here grease is there. When grease is there on the cloth, what you are doing? We are applying the moisture. Moisture helps in the weakening the bond between the fabric and the grease. Okay, then we are applying the soap or detergent. Soap, what it is doing? Soap is just comes in contact with the grease. Which part of the soap? R part. Which R part? C17H35. And that part is known as which? Hydrophobic. And that part is head or tail? It is a tail. And it means head will be towards us. If you are washing clothes, the tail would be towards that grease, and the polar part will be towards us. Okay, so this you can see from the diagram. The grease, the R part is towards the grease, and the polar part is towards us, outside, means facing us. Now what will happen? These particles will associate, they will join together, and that happens only at some particular concentration, that is known as critical micellization concentration. And now that is the reason that when we are saying that soap action is good at some warm temperature, or not at cold temperature, not at hot temperature. What is the reason? That the craft temperature. That is the temperature at which micellization takes place, and critical micellization concentration is achieved, then only soap will act in the best possible manner. Okay, so now this soap, what it is doing, R part being a non-polar part, being hydrophobic in nature, that will dissolve the grease. Once it is dissolving the grease has been taken up by the R part, and now when you wash the clothes, wash means splash the water, what will happen? The polar part will be attached with the water, and the grease and the soap molecule will be going out from in the washings. So means to say that our fabric will be cleaned one, now free from grease. So this is the soap action, where I would like to tell you one more thing. Soap is RCOONA, R is what? C17H35CONA, sodium stearate, sodium salt of fatty acid. So fatty acid COOH, H is replaced by Na, sodium salt of fatty acids. So this is why the R part is hydrophobic, and this is a tail, and head is towards the who is washing the clothes, and the tail will be loosening the bond between the grease and the fabric, and it will dissolve the grease, and when you splash water or wash with water, rinse with water, this grease will go along with the soap molecules, and this is the critical micellization concentration taking place, and craft temperature and CMC is important in this cleansing action of soap. Okay, so now what we have studied so far, we have discussed not about the crystalloids. Now we are going to discuss about only with the colloidal state, and what state says that the particle size is 1 nanometer to 100 nanometer, and colloidal particle classification we have discussed on the basis of dispersed phase and dispersion medium and 8 different systems. With example we have discussed nature of interaction. 2 classification we can discuss, dispersed phase and dispersion medium, and different properties also we are discussing that with examples. And next is lyophilic, lyophobic, that part. Third is in the basis of type of particles of the dispersed phase, like multi, that is very small size, and macro, that is very large size, like polymers and all that. Associated, this is taking place at particular concentration. So the thought I would like to repeat: every morning when you wake up, you have 2 choices, be positive or be negative. That is your choice. And thank you for your patient listening. Thank you.